Welcome back to Chemistry. It is all that matters, and we are going to talk today about average atomic mass. So, what is the difference between atomic mass and this thing we call AMU? Well, if we look at the carbon box for the element on the periodic table, we notice that carbon has an atomic number of 6, which means it has 6 protons, and normally carbon has 6 neutrons, then the mass should be 12. However, on the periodic table, we see that the actual periodic table mass is 12.01. So why is it 12.01? Where does that 0.01 come from? Is it the mass of the electrons? Well, no. The electrons are so negligible. They are so small in mass that they really have no effect. So instead, what we have to understand is this, that for carbon, the normal carbon atom has 6 protons and 6 neutrons, which means it has 12 atomic mass units. If we remember back to the chapter when we talked about subatomic particles, we said that each proton and each neutron represented 1 atomic mass unit. So technically, the mass number, which we call the AMU, atomic mass unit, is 12 for carbon. So this 12.01, what is it? Well, it's actually the average of all the different types of carbon on the planet. So basically what we know is that there are 3 isotopes for carbon. There's carbon-12, which is 98.8% of the carbon on the planet. There's carbon-13, which represents about 1.08% of the planet, and carbon-14, which is about 0.01% of the carbon on Earth. So what we need to do is understand how we use these numbers to calculate what is called the average mass of carbon on Earth, and that's where we get that answer of 12.01. So let's look at that. So here we have the 3 types of carbon found on planet Earth. There's carbon-12, which has a mass of 12.00, and that's represented by 98.8% of the atoms of carbon found on the planet Earth. And carbon-13, 13.003355 is the mass of that carbon-13, and that's representative of 1.08% of the carbon on Earth. And then carbon-14 is 14.003242 for a mass and represents 0.01% of the carbon on the planet. So when we take those values for percent, we end up going 12.00 times 0.988, which gives us a value of 11.856. 13.003355 times 0.0108, remembering to move the decimal 2 to the left, to give us a value of 0.140. And then 14.003242 times 0.0001, which gives us a value of 0.015. Now adding this up, we actually get a value of 12.011, and on our periodic table we've rounded all our values to 2 decimal places, so that's why on our periodic table it says 12.01. The actual best value would be 12.011, and that again is the average of the atomic masses of all the carbon found on the planet, based on the fact that there are 3 isotopes of carbon, carbon-12, carbon-13, and carbon-14. So let's look at another example of that, and here we have the 3 isotopes of oxygen, 16, which is actually 15.994915, and that's 99.76% of the oxygen on the planet. Oxygen 17, which is represented by 0.038% of the oxygen, and then we have oxygen 18, which is 0.2% of the oxygen on the planet. Now when we add all these up, we actually get a value of 15.989, and on our periodic table it's 15.99. However, most of the time for oxygen, people simply round to 16.0. So let's do one of those problems together. And here we have iodine, which is 80% I-127, 17% I-126, and 3% I-128. So calculate the average atomic mass of iodine. So go ahead and turn off the video. work this out on a separate piece of paper and then see how you did by coming back and checking your results. So go ahead and turn off the video now. So of course the first thing you would want to do is list your masses and the percents. So 80% of 127 is 0.80 times 127. 17% of 126 would be 0.17 times 126, and 3% of 128 is 0.03 times 128. When we take those values, we end up with 101.06, 21.42, and 3.84, which comes to a grand total of 126.32 for the average atomic mass of iodine. So this is how we calculate the average atomic mass, which is the mass found on the periodic table, and again it is the average of all of the isotopes of that particular element found on Earth. And that is different from the AMU, which is also called the mass number, which is simply taking the protons and adding them to the neutrons found in the nucleus, and that would give us what is called the AMU, atomic mass unit value, and that's usually a whole number, and that is also called the mass number. So hopefully this was helpful for you to see how we get those values on the periodic table, and keep working on your chemistry.